Hello, I'm Sunwoo. For our main Dart file, we initialize Firebase and we navigate to main screen. Before diving into screens, I will talk about API I used, which is Open Weather Map API. First, I created modules folder that have weather.dart. The purpose of this is to convert the JSON file from API, as you can see from here, into further appropriate variables like double wind speed, string condition, final daytime time, so on. I used factory to convert and return the data, and the weather dot from hourly JSON will be used for both hourly forecast and daily forecast because there was limitation of free plan for Open Weather Map API. So I had to use this format for both hourly and daily forecast. Next, I created service folder with API services.dart. This is where we utilize API. I saved API key and base URL to successfully access Open Weather Maps API, and fetch weather hourly uses base URL, API key, and latitude and longitude from geolocator to the cast API we need. If we get response, we decode JSON into list called forecast list, and then we only take 9 because free plan of API gave total of 40, which is 5 day with 3-hour interval, and we only need 1 day for hourly forecast, so we take 9. And then using weather from hourly JSON from models, we convert JSON and their type and set their type as weather so that we can use them in the future. Fetch weather daily is very similar to fetch weather hourly. It will be used for daily forecast, but the logic is pretty much same. We use base URL, latitude, longitude, API key to get the response, and then after we get response, we decode the JSON. But the different thing is that we don't need all 40 items. We only need 1 items per day. So we defined date key using weather.time.year, weather.time.month, weather.time.day. So we use date key to filter the list. So we only take 1 data per one date. So if the date key does not exist, we add the data. If it exists, we move on until we found the date key that does not exist. Main screen.dart is code for our main screen. So first we declare location, longitude, latitude that will be used for geolocator. And then we initialize different functions like init Firebase message or load background for future use using init state. And the get current position function grabs the user's location automatically. So what it does is it first asks for user's permission to get the location. When it does, it will get the user's latitude and longitude to find the user's location. But in order to make it more user friendly, utilize geocoding to change latitude and longitude into city, state, country. And then after that, we use setState to update the location, latitude, and longitude. So for the future use. I also implemented manual input location. So there is text field where user can enter their manual location. And when user do that, it's gonna call the convert address function. What convert address function does is that it utilize both geolocator and geocoding so that when user enter Atlanta, it's gonna get the latitude and longitude of it. So using that latitude and longitude, we're gonna find much detailed information, city, state, and country. So when user enter Atlanta, it will display Atlanta, Georgia, United States. So that location will be displayed on top of the main screen, and then at the bottom there will be text info field, and then at the bottom there will be elevated button called auto detect location that calls the get current position to get the to auto detect the location. Main screen, I also implemented alert notification. It allows us to receive and handle the message sent from Firebase. Not only that, it's gonna filter the notification based on user's alert setting. So first, what it does is first it's gonna save the title and the body of the message sent as a lowercase, which will be used in the show message dialog to create the pop-up. And then it's gonna check if title contains rain or snow. And if it contains rain, it's gonna check the alert settings for the rain in Firebase. And if that is true, if it is on, then it's gonna show the message by setting the show message equals true. And for temperature, it's a little bit different. It's gonna check if title contains high or low. So if it is high, it's gonna compare if the alert temperature is higher than user set it temperature. If it's low, it's gonna check if it is lower than the user set it temperature. So we can grab that temperature from message by using regex, and then it's gonna compare that and do the same. If it's true, it's gonna set show message true, and vice versa. This is my main screen UI. I used elevate button to navigate to forecast screen and settings. So for forecast screen, I'm gonna pass latitude, longitude, and location name. And I also used double dot infinity to make button fit the width of screen. For my forecast screen, I'm going to make sure I grab latitude, longitude, and location name from main, and I'm going to create list for both hourly and daily forecasts. And I will create fetch weather function that saves the hourly forecast into the hourly by calling the weather service.fetch weather hourly from API service.dot, and it's gonna use the latitude and longitude we got from main. Same thing for daily, but we use fetch weather daily, and then we're gonna update the weather by using set state. For forecasts, we need to display appropriate dynamic images. In order to do that, I came up with this group weather and get weather image function. So the weather data is saved as condition, and so we're gonna check if the condition contains the keywords like sun or clear. If it contains sun or clear, it's gonna return sunny. If it contains cloud, it's gonna return cloudy. And using that return condition, we're gonna get weather images by using switch function. So if the case is sunny, it's gonna return asset sunny.png, and so on. The UI for forecast screen. So on top, we will display location, and below we are gonna represent what kind of forecast we are displaying and the local time, and only gonna show the date. And then below there will be two elevate button named hourly and daily that change the state of show hourly, which will be used to determine what kind of forecast is displayed. This is the main logic to display the forecast. We are gonna use list_view.builder to represent the list of cars that contains date, weather condition, temperature, humidity, and wind speed, and then image, which will be grabbed by the getWeatherImage function we described before, and then it's gonna decide either it's going to be hourly or daily by using show hourly. So if show hourly is true, then it's gonna represent hourly forecast. And if it is false, it's gonna display daily forecast. So by clicking the hourly button, it's gonna display the hourly forecast. By clicking the daily, it's gonna represent the daily forecast. For settings screen, I implemented personalized alert settings. It will be mainly focused on Firebase integration. There will be three kinds of alert. User can toggle on and off to decide whether to get notification or not. It will be lane, snow, temperature. The update alert function creates default document under settings. On Firebase, Flush is gonna create theme as well to save the pathway to background image. And the load alert going to load the default document in Firebase. Image picker package is used to allow user to upload personal background. It will ask for permission first, and if permission is granted, it will display UI for user to choose image. It will say path of picked image as background image, and for every screen, the body will be wrapped by container with box decoration that sets background image. So it's gonna check if background image starts with assets or not. If it starts with assets, it's gonna use asset image. Else it's gonna use fire image. It is because image picker uh use different type than the assets. Different elevated buttons are used to choose mood-based background. So if you push happy button, it's gonna set background image as assets happy.jpg. If you push sad, it's gonna set assets sad.jpg and so on. If you push upload button, it will record the pick image function to allow user to pick personal image. And all these background image paths will be saved and updated in Firebase by calling update alert at the end. This is how finalized setting screen looks like. I used the switch list tile to toggle lane and snow alert. This adds switch button at the list tile, so when you turn it on and off, the boolean state of each alert going to changes accordingly. And for temperature, I used a normal list tile with slider, so user can change the temperature using slider. And finally, I added update change setting button, so when you push it, it's gonna call the update alert, which update and saves all those alert settings in the Firebase.
Interactive map part 1 displays an interactive map that automatically centers on the user's live GPS location. Provides a balanced zoom level to show local and regional weather coverage clearly. It dynamically switches between Street View, OpenStreetMap, and Satellite View S3 ArcGIS based on the user's selection. Ensures location names remain visible in satellite mode by layering city labels on top of the satellite tiles. Enhances clarity and usability by integrating well-known public mapping APIs. Interactive Map Part 2. This screen overlays real-time weather data, either precipitation or cloud coverage, directly on top of the base map. This screen uses Open Weather Map tile APIs, which provide global weather visualization as map tiles. It automatically adjusts based on the selected map type. The radar mode shows rainfall and snow intensity with a semi-transparent precipitation new overlay. The satellite mode adds clouds new tiles to show moving cloud patterns. The transparency opacity is set to avoid fully obscuring the base map, balancing readability and visibility. Interactive Map Part 3. This screen provides two clear buttons labeled as radar and satellite, allowing users to switch between map views. Set satellite updates the map type variable dynamically, triggering the display of the correct map tiles and weather overlays. Background color changes is based on which mode is active, improving visual feedback for the user. Community Report Part 1. This screen displays a text field where users can describe the current weather in their location. An example, windy here, or it just started raining. This uses a text editing controller to capture and manage user input. The send button triggers the submit report function, which saves the input to the Firebase Firestore along with the user's location and a timestamp. Community Report Part 2. This automatically loads recent messages from all users using the local reports function sorted by time. Each report is shown as a list tile with the message and timestamp. This also includes the location from the main screen to give local context. This enables real-time community space where users can observe weather trends or visual events.
This meeting is being recorded.
Hello, I'm Sunwoo Yeom. In this video, I'm going to demonstrate my project to WeatherApp. This is my main screen. There are more features coming up after my partner finishes her working, but in this video, I'm going to focus on the features that I worked on. So I worked on auto detect location. So if I click this, it's going to grab the location automatically. And it is a little bit off because I'm using emulator, but it works fine in your phone. And I can enter location manually. I can enter Atlanta and then add this button. Then it says your location is updated. And if I click on forecast, this is the forecast screen. I can see the location of Atlanta hourly forecast of April 19th, and I can see the hourly forecast. And if I click on daily, I can see the daily forecast. And if I go to settings screen, this is the alert toggle button. So here the rain alert is off, snow alert is on, and temperature alert is on. And then this is the background change. So if I click this, it's gonna change. And then if I click upload, it's gonna ask for the access to the photos. And if I say allow limited access, then I can access to the images. And then after that, I will test on the notification. So if I send the lane alert, it should not be displaying it because that was toggled as off. If I send this, yes, it says notification is filtered out based on settings. But if I click on settings and if I click on and then update the change settings, and then if I go back and send test message again, boom, it's showing the alert. And then if I change the title to snow, it's lagging. Snow, and then send test message. Then it's working. And then if I say high temperature, alert, and then it was say 90, it's gonna work. But if I say 7, which is below the set temperature, it says that notification filtered out based on the settings. Thank you.
Hello, my name is Ikran Ahmed, and I'm going to present the interactive map and the community report features of this app. So I entered my location and it appears on the top part of this screen. And when I click on the interactive map, it shows me the radar map of the Atlanta area. So we can see the layering of the precipitation on the map as well. And when we click on satellite mode, It will also show you the clouds precipitation. And yeah, this is the map feature for this app. And for the community reports, since we have the location set to Atlanta, Georgia, when we put the report for our report, we can put it is sunny right now. So when we click this report, it will be sent to the database, and that is it for the features of this app. Thank you.